This video is part of our Ultimate Study Skills series, and today we're talking about how to review for exams using practice questions or past papers. During med school, I remember going through massive QBanks on UWorld for big exams like the MCAT or the USMLE. Massive, like literally thousands of practice problems. But I've also taken classes where I was only given a few past papers, and I still made it work. And so I realized it doesn't matter if you have 10 practice problems or 10,000. If you're not using them properly, then it's gonna be a waste of time. So how is this done? The most important idea to understand here is confidence. You know when you use flashcard apps like Anki or Remnote, after you answer the flashcard in your head and reveal the answer, it asks you to rate how well you know it. That's the important part. It's asking, how confident were you with that decision? I would argue that it's smarter to rank your confidence before even checking the answer. Because it's not enough to just get the answers right. You also need to be confident that you know the answer and that you'll get it right again. When we're confident that we know something, but it turns out that we were wrong, that piece of information is way more likely to stick in our memory. In psychology, this is called the hypercorrection effect. Like, I remember once I got into it with my friend that the main villain in Lord of the Rings was Saruman, and we got in this heated argument about it. Then it turns out I was wrong, and it's Sauron, not Saruman. Lost $50 for it, and so yeah, I'm never gonna forget that again. So here's a 3-step framework to raise your confidence when reviewing practice problems. Step 1 is to always make sure you know why the right answer is right and why the wrong answers are wrong. That's why it's always helpful to have an answer key to check your answers. And you want the answer key to be a detailed explanation, so it explains the thought process. Step 2 is to change the variables of the answer choices or change the variables of the question itself. So for example, if you know why the wrong answers are wrong, how would you change the wrong answers to then make them right? Or how would you change the question itself so that the wrong answers would be right? Because once you can start manipulating the questions and the answers, you'll start to think like an exam writer. I would say try to go even deeper and ask yourself, how could this question be asked differently on the test? Or ask, how could the teacher ask a curveball question or combine multiple variables into the same question? So now I'm going to use tips number 1 and 2 on some practice problems to see how this all works. And because I love triangles, let's do some trig. So let's draw out a right triangle here, like that. It's actually pretty good. And let's say this side here is a 4, this one over here is 6, and we'll be solving for this length here, which is x. And I'll put some answer choices from this problem set here. So A is going to be 12, B is going to be 7.2, and C is 17.2. So from my long lost memory of trigonometry and from Googling it like 20 minutes ago, I recall that to find the hypotenuse of a right triangle, the long side that's opposite from that right angle, it can be found using the Pythagorean theorem. So the Pythagorean theorem, I think I spelled that right, which is also equal to a squared plus b squared equals c squared. C being the length of the hypotenuse, the long side. So with some simple plug and chug, we get 4 squared plus 6 squared equals c squared. Simplifying this down, we're going to get 16 plus 36 equals c squared. 16 plus 36, what is that? 52 equals c squared. And finally, we just take the square root of each side because this one has a squared over here. Plug that into your calculator or Wolfram Alpha or whatever, and we'll get that c is equal to 7.2. And that makes B the correct answer choice. Now, what if this one practice problem was all you had to study for your upcoming quiz? We can use tips 1 and 2 to learn a lot more from this problem. So tip number 1 is to know why all the wrong answers are incorrect and why the right answer is correct, right? For math, this is much more black and white. Like obviously I can just Google square root of 52 and I'll know that it equals 7.2, not 12 or 17.2, right? But I can also stop and think more carefully about why answers A and C were included at all. Like why is 12 and why is 17.2 possible answers that it could have gotten given this situation? So from the limited amount of information that was given from this problem, what else could I actually solve for, right? Well, I also know that I can find the area of a right triangle if I have the height and base of the triangle. And those are 2 variables that I am given. So the area of a triangle is equal to the height times base divided by 2. Let's do some simple plug and chug here. We have the height of 6 times the base of 4 divided by 2. And that is going to equal, doing simple math in my head, 12. Okay, cool. So answer choice A was solving for the area of a triangle, whereas B was testing for my knowledge of the Pythagorean theorem. What about C? I see a 0.2 there, that decimal, and answer B, which we just solved for, which was the hypotenuse, was 7.2. So the only other variable that I can think of that would be equal to 17.2 would be the perimeter of a triangle, right? Just adding each side length together. The perimeter of a triangle is equal to A plus B plus C. Plugging all of those in, we would also get 4 plus 6 plus 7.2. Since we just solved for it in the Pythagorean theorem, this is going to equal 17.2. So C is solving for the perimeter of a triangle. So now I know why answer choices A and C were wrong. They were using different formulas, one for the area of a triangle, one for the perimeter. And now I know why B was correct, because we used the Pythagorean theorem, which was the right formula for that equation. Now let's move on to tip number 2. How can I actually change the conditions so that I would solve for a different variable of this equation overall? Like, what would it look like if instead of getting this here, I was actually given 7.2 and asked to solve for this variable right here? How would that change the way that I applied the Pythagorean theorem? So we can just kind of do the same plug and chug as we just did before. But this time it would look like this. We would have a squared
plus 6 squared equals to 7.2 squared. Simplifying that again, we would get a squared plus 36 equal to 52. And then we could just subtract 36 from both sides. I would get a squared is equal to 16. I would then take the square root of a and 16.
And that would give me this final answer of a equals to 4, right? All right, let's do another one. What if, for example, this angle right here was unknown? It wasn't right angle. That means that the Pythagorean theorem wouldn't apply, right? I would have to use a different formula, right? Like the law of cosines. So we go in, so the law of cosines is equal to C. It's equal to the square root of a squared plus b squared. That looks bad. Plus b squared minus 2ab cosine of that angle. So you see, I can just keep manipulating this one practice problem to generate a whole different set of problems to solve for, applying different constraints to solve for different variables. Like, how would I solve for this angle instead? How would I solve for this angle if it was a right triangle? What if this was a completely different shape, like it had another triangle over here? What if it was three-dimensional, and it had this shape like that? How would that change solving for different angles? How would this change the way that I approach this problem? So effectively, I can turn this one practice problem into like 10 problems or more. This is such an underrated way to learn because it emphasizes making connections between topics and really challenging yourself to think more deeply. Connecting ideas like this differentiates them and makes them more applicable and usable in different situations. And remember that this is what your teachers are doing when they write exam questions. They're testing your ability to manipulate and distinguish between different kinds of concepts. All right, so let's get back to the framework. The last tip actually happens after you finish reviewing the problems for the day, and it's a really important step. You have to track your confidence for every topic you study. Otherwise, you'll end up wasting precious time reviewing past papers or even entire chapters that didn't need to be reviewed. There are different ways to do this, from the old school analog shoebox method to encoding entire algorithms, but let's be real, the simpler the better. Our preferred way is something we call the GROW method. Not only does it keep track of how well I know each topic, but it also serves as a study schedule that recommends which topics to study at any given moment, which is a huge time saver because I don't need to worry about planning a schedule ahead of time. But I go way more into detail with a step-by-step walkthrough on the GROW method in this video right over here, and you won't want to miss it. All right, bye.